Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we are going to talk about convex hull. So this topic you can find it out in unit 2 as the last topic. Now let's understand what is convex hull problem and how to solve this problem using brute force approach. Now, a convex hull is an important structure in geometry that can be used in the construction of many other geometrical structures. The convex hull of a set of S points in the plane is defined to be the smallest convex polygon containing all the points of S. Now let us assume that I have some set of points. So when I consider all the point of S, then it is called as a polygon, convex polygon. So I can call this also a convex polygon. I can call this is convex polygon. Now can I also call this is convex polygon? Let's see the differences in between these two. I can call these two as polygon. Yes, I can call these two as polygon, but I cannot call these two as convex polygons. So how to differ one polygon with the convex polygon? So that we'll see with an example. First of all polygons are not called as convex polygons. That a polygon is defined to be convex if and only if for any 2 points of P1 and P2 inside the polygon, the directed line segment from P1 to P2 denoted P1 comma P2 is fully contained in the polygon. Now let's see some example to understand the same. I am just taking these set of points yes for the some example. Now let's see, here both are polygons and this is called as convex polygon. Why? Because if I take any 2 points of any corner of the polygon, I can draw a line segment and say that all these are inside of the polygon. If I do the same thing for this polygon, if I take the same, if I draw this line, yes, it is inside of the polygon. It is inside of the polygon. If you draw a line segment from this point to this point, name it P1 comma P2. When you draw a line segment from P1 comma P2, it is not fully contained inside of the polygon. Only some portion is covered, but some portion is outside of the polygon. Hence, it is never be called as a convex polygon. By mathematical definition, if you join any 2 points, it will lie completely within the polygon. So as far as that definition is considered, the first is called as what? Convex polygon. The second is called as not convex, because when I join these 2 lines, it is not covered fully. So hence it is not convex polygon. Now focus this polygon. Now focus convex hull. Now and find out all possible convex hulls and find out the shortest one in order to call it is a convex hull. Now let's see one problem over here. The vertex of the convex hull of a set of S of points form a subset of S. So all the points of S are inside of your main set of S. So that means if you consider these points are P, if you consider these outer points are S, always P should be belongs to S. Then it is called as convex hull. Now you can take some parameters. There are 2 variants of the convex hull problem. One is obtain the vertex. Here vertex is nothing but extreme point, and will obtain the vertex which can be included to be called as convex hull based upon some order. That order is example clockwise, anti-clockwise, the order what you are following based upon the algorithm. According to that order only you have to find out the extreme points what it can comes under. Now let's understand with this example. Now so there are algorithms also to find out the solution for convex hull, but I wanted to give you the outline for these 2 things what I have given in the PPT. So let us understand that if I wanted to draw a line segment from this to this, To join this line, to join this point, I have to turn to right side, right? So that means I have to calculate the angle from this point to this point. The same way, if I am just wanted to join this line to this line, again I have to turn, right? So I have to calculate the angle from this point to this point. So we will be implementing the algorithm. Based upon the algorithm, we'll follow the order, whether to follow the clockwise order or to follow the anti-clockwise order, that we will be. And here is a simple algorithm for obtaining the extreme points of a given set S of points in the plane. The algorithm is what? To check whether a particular point P belongs to S is extreme, look at each possible triplet of points and see whether P lies in the triangle formed by these 3 points. Now if you see any example, now I am taking this example. Now as far as this basic algorithm is considered, you have to draw a triangle with the triplets with 3 points. If it is possible, then it is what? Convex hull. If it is not possible to draw a triangle, then it will be not. So now look at this. I am not going to take this point, I am just going to take this point, whereas I can make a triangle. So this one point is outside of the convex, right? Now this is what the basic algorithm is, to consider which vertex to be part of your convex and which are not. And testing whether P lies in a given triangle can be done big O of one time. Since there are big O of n square possible triangles, it takes the same time, that means theta of n square, to determine whether given point is an extreme point or not. Since there are end points, this algorithm runs in total of big O of n power 4 times. And using divide and conquer, we can solve both versions of the convex Hall problem using in theta of n log n time. We developed 3 algorithms for the convex Hall. There are 3 algorithms. One algorithm, the first has the worst case time of theta of n square, whereas its average time is what? Theta of n log n. And this algorithm has a divide and conquer structure similar to the quicksort. The second has a worst case time complexity, and that is big O of or theta of n log n, and it is not based on the divide and conquer. The third algorithm is based on divide and conquer and has the time complexity of theta of n log n in the worst case. So the time complexity of convex Hall is what? Theta of n log n in various algorithms. In gram-scan algorithm and using divide and conquer approach in a basic algorithm, the time complexity of convex Hall is what? Theta of n log n. So to understand convex Hall procedure, we will be having some mathematical theory. That is, let us assume A be some n by n matrix. Let A be a n by n matrix whose elements are A, I, J. That means 1 less than or equal to I, J less than or equal to n. And the ijth minor of A, denoted as Aij, is defined to be submatrix of A obtained by deleting the ith row and jth column. That means the determinant of A, denoted det of A, is given by, if your n size is only 1, then we'll take A11 as the det of A. If n value is greater than 1, then the formula is what? A11 det of A11 minus A12 det of A12 plus dash dash minus 1 power n minus 1 det of A of 1 n. Consider the directed line segment P1 comma P2 from some point P1 is equal to x1 comma y1. The other point P2 is equal to x2 comma y2. That means take any 3 points. I am taking these 3 points. So this point is P, this point is Q, this point is R. So this point is what? X1, Y1. This point is what? X2, Y2. This point is X3, Y3. Now, we say Q is the left of P1 comma P2 if the angle P1 P2 Q is left turn. An angle is said to be a left turn if it is less than or equal to 180 degrees, correct? We can check whether Q is to the left or right of P1 comma P2 by evaluating the determinant of the following matrix, that is x1, x2, x3, y1, y2, y3, 1, 1. So we'll find out the determinant of this matrix. If this determinant is positive, if the determinant is positive, x1, x2, x3, those 3 points what we were taken P, Q, R, that determinant, if it is positive, then Q is 0. That means Q is to the left of P1, P2. If the determinant is 0, the 3 points are collinear. This test can be used, for example, to check whether a given point P is within a triangle formed by 3 points P1, P2, some P3. Now, so when it is less than 0, then these P1, P2, P3 are clockwise order. That means this order P1, P2, P3. The point P within the triangle if and only if P is to the right of the line segment P1 comma P2, P2, P3, P3, P1. Also for any 3 points x1, y1, x2, y2 and x3, y3, the signed area formed by the corresponding triangle is given by 1/2 of the above determinant. So now here let's understand. Let P1, P2, Pn be the vertices of the convex polygon. Q in clockwise order. That means P1, P2 and P3 or clockwise order. If I draw a line which is Q, convex polygon Q in a clockwise order, let P be any other point. It is desired to check whether P lies in the interior Q or outside of the Q. Consider a horizontal line which is H that extends from minus infinity to plus infinity and goes through P. There are two possibilities. H does not intersect any of the edge of Q or H intersects some of the edge of Q. If it is the case, if the first condition is true, if H does not intersect any of the edge, if it is true, then P is outside of the Q. P is outside of the Q. If it is not, P is inside of the Q. So in the next video, we'll take some example and we'll solve using Graham-Scan algorithm. Thank you.